All right, so chapter 5, lesson 4, we're going to be talking about writing equations in slope-intercept form. So we've written equations that they give you the slope and the y-intercept. And so in this one, we're going to be writing equations still in that same form, but we're going to be provided different information. Sometimes it might not be as easy as just given the slope and the y-intercept. Sometimes you might have to put in a little bit of work. So what we're going to learn is we're going to learn how to write an equation. If you're given the slope and a point, we're going to learn how to write an equation if you're given 2 points and no slope. So some vocabulary to keep in mind is linear extrapolation. I know it's kind of a hard word. Extrapolation. And so let's look at something here. It says, how can slope-intercept form be used to make predictions? So it says in 1995, the population of Orlando, Florida was about 175,000. And at that time, the population was growing at a rate of about 2,000 per year. So here you can kind of see a table. Every year it was going up by 2,000 people. And so here you can see a graph of that. So again, every 1 year it was going up 2,000, right? And so you could write an equation for the slope based off the slope here that would predict the population, right? So we know that it's going up 2,000 every 1 year. We could write a line in slope-intercept form for this. Okay, so that's what this lesson is going to be all about. So let's take a look. So it says, write an equation given the slope in 1 point. You have learned how to write an equation of a line when you know the slope and a specific point, that point being the y-intercept. So if you were given the slope and the y-intercept, you could write the equation. That's what we did in the last lesson. Well, in this lesson, we're going to be showing you how to write an equation when you know the slope and any point on the line, not just the y-intercept. So here's an example. So write an equation given the slope in 1 point. So write the equation of a line that passes through the point 1, 5, right? That's an x and y coordinate with the slope of 2. So in order to do this problem, we're going to first take the slope, right, 2, which we know how to put that into the equation, but we don't know what the y-intercept is, okay? So we're going to still be using our slope form equation, but if you notice, we know what m is, we know what the slope is, right? The slope is 2, but we don't know what the y-intercept is. We don't know what b is. All they're giving us is a point. Well, if you remember, that point, 1, 5, is an x-coordinate and a y-coordinate. Well, guess what? My equation has an x and a y. So see these 3 variables here? I can replace all of them with the correct numbers. So 2 can go in for my slope m. 1 can go in for my x, because it's my x-coordinate. 5 can go in for y, because that's my y-coordinate. And if I put those into the equation, right, put all these numbers in the right spot, I'm left with an equation with 1 variable. That variable is my y-intercept, my b, right? So I'm going to go ahead and solve for it. So first thing I'm going to do is 2 times 1, which is 2. Then I'm going to subtract 2 from both sides, right, because I'm trying to get the b by itself. So subtract 2 from both sides, and I get b is equal to 3. So now I know my y-intercept. So now I know what my y-intercept is, and I know what my slope is, right? My slope is 2. They gave me that at the beginning, and I found my y-intercept 3. So now, just like in our other problems, all I have to do is put the m and the b in, right? The slope and the y-intercept in. So if I put those in, my equation is going to be y equals 2x plus 3, right? I can't simplify it any farther, so that would be my final answer. So now it says, well, what about if you're going to write an equation and you're only given 2 points, right? Sometimes you don't know what the slope is of a line, but you know 2 of the points that are on the line. Well, in that case, we're going to use what we used in the first lesson in this chapter, which is when I have 2 points, I can find the slope of that, right? So let's go ahead and look at an example. So problem number 2 says write an equation given 2 points. So it says the table of ordered pairs shows the coordinates of 2 points. So here's a table, x, y coordinates, right? And it says take those 2 points and describe a equation, right, that would graph that. So the table represents the ordered pairs -3, -1, and the points 6, -4, right? So these are my 2 ordered pairs that I get from my table. So now I have to find a line or the equation to that line. So first thing I'm going to do is I need a slope and a y-intercept. Well, I know I have 2 points, so that means I can find the slope, right? Right? X sub 1, y sub 1, x sub 2, y sub 2, right? So just take your 2 points and use your slope formula like we did in the first lesson, right? Subtract the y values from each other, subtract the x values from each other, right? So -4 minus -1, that's like -4 plus 1, which is -3. 6 minus -3, that's like 6 plus 3, which is 9. So I get -3 over 9. Remember, 3 over 9 simplifies to 1 over 3, right? And it's just negative, right? So -1/3 would be my slope. So step 2 would be, well, now that I have a slope, I need to have the y-intercept. Well, I'm going to go ahead and take one of my 2 points. I'm going to use the point 6, -4, and it doesn't matter what point you pick. You could have picked this point or that point, but I'm just going to use this point. And I'm going to go ahead and I'm going to use that point and the slope that I found, -1/3, and I'm going to put them in to find the y-intercept, right? So my slope I'm going to put in for m, right, -1/3. My x value is going to be 6. My y value is going to be -4. So I'm going to put those values in. And then I can just simplify. -1/3 times 6 gives me -2. And then I got to get the b by itself because I'm solving for b. So I got to add 2 to both sides, right? And that's going to give me b is equal to -2. So now I've found the slope and I've found the y-intercept. So now it goes to step 3. The step 3 is I'm going to use my slope that I found and my y-intercept to write my slope-intercept form equation, right? Replace m, right, with -1/3. Replace b with -2. And then that would be my equation. Y equals -1/3 x minus 2, right? And I can't be simplified any further, so that would be my final answer. So here's a kind of concept summary of what we did, and you might want to write this down. When you're writing equations, if you're given a slope in one point, step 1, substitute in your m, your x, and your y, right? Your m would be your slope, and your x and y come from the point they give you into the slope-intercept form, and then solve for b, solve for the y-intercept. Once you have your slope-intercept form, right, using your b value, once you have that, you can use your slope and your y-intercept, your m and your b, and you can put them into the equation. Well, when we're given 2 points, a little bit of an added couple of steps. First thing is, with 2 points, you can always find the slope, right? Y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And then step 2 says choose one of the 2 points to use as your x and y coordinate, and then follow the procedures from before, right? Use one of the points and the slope you found to find the y-intercept, and then use that y-intercept and the slope to put into the equation. So let's look at a problem where we're going to do a word problem here. It says, in the middle of the 1998 baseball season, Mark McGwire seemed to be on track to break the record for the most runs batted in. After 40 games, McGwire had 45 runs batted in. After 86 games, he had 87 runs batted in. Write a linear equation to estimate the number of runs batted in for any number of games that season. So first, let's explore. Well, we know that the number of runs for after 40 games and for after 86 games. And so we're going to let x represent the number of games. We're going to let y represent the number of runs batted in. And we're going to write an equation of a line that passes through the points 40, 45, right? So 40 games, 45 runs batted in, and 86 games and 87 runs batted in. So if I were to look at it on a graph, it would look something like this, right? So that's 40 games and 45 runs batted in, 86 games, 87 runs batted in. So I can see that it would make this line here, but I'm trying to write the equation for this line. So I'm going to use these 2 points. So first, I got to find the slope. So again, these are like my xy coordinates. I'm going to use those 2 points to find the slope. So I'm going to use my slope formula, right? So put in my y values, put in my x values. I'm going to go ahead and subtract them. So 87 minus 45 is 42. 86 minus 40 is 46. And so this would really be my exact slope, 42 over 46. I could simplify it to like 21 over 23. But in this scenario, you could round it to 0.91 if you wanted to a decimal. Typically, I don't recommend it, but you could if you wanted to estimate. So we have our slope, right? So now we want to use one of the points. Let's use the smaller point because it's got smaller numbers. And we're going to use that to find our b, our y-intercept. So here's our equation. We're going to substitute our slope in and substitute our x and y values in, right? 40 is the x value, 45 is the y value. And I put in my slope. And then now I'm just going to solve for b, right? So 0.91 times 40 is 36.4. Subtract 36.4 from both sides, and that gives me 8.6. So now that would tell me that my y-intercept would be 8.6. And now that I have my slope and my y-intercept, I'm going to go ahead and write my equation. So again, m is my slope, b is my y-intercept. I've already found those, put them in the right spot, and that would be the equation. Y equals 0.91x plus 8.6. So that is how you would write an equation for a story problem. If you have 2 points, just like the other problems, find the slope, find the y-intercept, and then you can write your equation. So here's this thing about linear extrapolation, okay? When you use linear extrapolation, it helps you to predict values that are beyond the range of the data you are using, okay? So the record for most runs in a single season is 190. Using the equation from the previous example, example 3, decide whether a baseball fan following the 1998 season would have expected McGwire to break the record in the 162 games played that year. So remember, this was our data that we had, right? We had 40 games and 86 games. We knew what happened there. So what would happen if the games, because they went all the way to 162, what's going to happen way out here? Well, we're going to use our equation to extrapolate this line and figure out what that should look like. We're going to use it as a prediction equation. So here's our equation that we got in the last problem, right? And these are our x and y values. So we want to predict what this line is going to reach in 162 games. So that's, remember, games are our x's. So I'm going to put 162 in for my x. And I can calculate to see how many hits or runs batted in that would give me. So 0.91 times 62 plus 8.6 is approximately 156. So the question is, would, if the record was 190, would 156 break it? The answer is they would have predicted no, he would not break it. Okay, so that's how you can use an equation to predict what's going to happen outside of the data range. Now, one last little note here. You want to be cautious when making a prediction because that's what it is just a prediction. This model is only approximately correct, but it still gives inaccurate predictions. For example, in 1998, the season they're talking about here, Mark McGwire had 147 runs batted in by the time the season was over, which is actually 9 less than the prediction. But I have to say, it's still pretty good. It's still a pretty good prediction. It still predicted that he wouldn't break the record. So, but anyways, that's how we write equations in slope-intercept form using different data and different pieces of information. All right, thanks for watching. Let me know if you have any questions.